NASA currently has something up its sleeve that may just change how rockets are launched into space forever. They are currently testing a cutting-edge launch system known as spin launch, which aims to revolutionize space travel by flinging payloads into orbit using centrifugal forces. This groundbreaking technology promises to take space exploration to unprecedented heights, with significantly reduced launch costs compared to conventional rockets. However, it remains to be seen how this new system will perform in practice and what other potential applications it could have beyond space travel. Let's delve deeper into this exciting development and explore its implications for space travel in the future. Spin launch is the brainchild of Jonathan Yaney, an experienced aerospace entrepreneur based in California, who has been working on this revolutionary technology since 2014. With the backing of industry titans such as Airbus and Google, the visionary project is now under contract with NASA and set to redefine the limits of human exploration and innovation. The basic idea behind spin launch involves propelling an object at high speeds along a circular track before launching it into the sky, which makes it possible to achieve escape velocity and break free from Earth's gravitational pull. However, the real challenge lies in reaching the dizzying speeds required to launch a significant payload into orbit. To pull it off, an object must be launched at a speed of 40,000 kilometers per hour. That's about 32 times the speed of sound. Considering the weight of payloads that are usually shot into space, this sounds like a challenging feat to accomplish. So how could this be possible? That's where the awe-inspiring spin launch facility comes into play. Standing at an impressive 308 feet tall and towering over the landscape like the Statue of Liberty, its launcher can currently reach speeds of up to 8,000 km/h, and at the heart of the technology lies the kinetic launcher. One end of the launcher is attached to an aerodynamic craft carrying the payload, while the other end is balanced by a counterweight. To reduce resistance, the chamber is emptied of air to create a vacuum, and as the spinning process begins, the craft and counterweight go to work, accelerating with each turn. Once the optimal speed is attained, the craft is catapulted into the sky, thus marking a significant milestone in space travel technology. However, the craft must still use its own propulsion system to continue the journey into outer space. Despite this limitation, the scaled-down prototype has already managed to reduce launch costs to $500,000. To put this into perspective, the cost of launching through SpaceX's rocket, the Falcon 9, is around $100 million. This means spin launch can reduce launch costs dramatically by a factor of 200. With the promise of cheaper and more accessible space travel, this cutting-edge technology is poised to change the face of the aerospace industry forever. Spin launch is still in its testing phase, but it is aiming to launch its first payload into space by 2025. As spin launch's technology evolves and matures into a full-scale kinetic accelerator, the costs are expected to decrease even more. Right now, the majority of expenses are related to the fuel consumed during the craft's second launch phase. However, if the accelerator can reach escape velocity without needing more fuel, Yaney believes that more nations can take part in spaceflight, as opposed to the present scenario where only the rich and most powerful countries can afford to explore space travel. The idea seems promising, but scaling up the operation could lead to significant problems. One issue is the integrity of the structure itself, as spinning a massive rotor with a several hundred-kilogram object at high speeds increases the risk of breakage. What could happen if the accelerator malfunctions? The payload could veer off course, turning the launch site into an inadvertent artillery platform. Instead of propelling the load high into the heavens, it can hurl it elsewhere and cause the destruction of nearby areas. What's worse is when those areas are full of innocent residents and bystanders. Say, for example, the payload weighs 200 kilograms and moves at 40,000 kilometers per hour. If such a heavy object makes contact with the ground at that speed, it would release 1.28 terajoules of energy upon impact, which is equivalent to detonating 300 tons of TNT. That's more powerful than the largest non-nuclear bomb in the U.S. military's inventory, the mother of all bombs, or Moab, which releases just 11 tons of TNT's energy. While the idea of transporting humans to space using spin launch may seem appealing, it's highly unlikely that technology will ever be advanced enough to do so. Even if a spacecraft were accelerated slowly enough to avoid dangerous G-forces, the centrifugal force would still be too intense for the human body to handle. At a speed of 40,000 kilo/h, a person would experience 10 tera-newton of force, which is equivalent to the weight of an entire skyscraper crashing down on them. It goes without saying that spinning at such speeds would result in a person being turned into a gory mess. Even at a lower speed of 8,000 km/h, the force exerted on a human body would be equivalent to that of a blue whale landing on them, making it an instant death sentence. Furthermore, any object launched using this technology must be made of materials that can withstand such incredible forces. As a result, the launch of more delicate probes and satellite equipment using this method is not feasible. Another matter of concern is the materials to be used. The materials for the objects to be launched must have the ability to endure such an incredible force, hence making it impossible to launch more delicate satellite equipment and probes with this technology. Advanced rocket propulsion and breakneck speeds of 8,000 kilometers per hour can only do so much when launching payloads into space. The type of fuel stored on board is a significant constraint. Traditional liquid-based rocket fuel, with its complex network of valves, pipes, and pumps, isn't ideal for the job. The intense accelerations and vibrations that occur during a high-intensity centrifugal launch require a more robust system, which hasn't yet been developed. Spin Launch's team and NASA have decided to use solid propellants for their launch crafts. While this decision has some benefits, there are drawbacks to this method. One of the most significant drawbacks is that it is less efficient and controllable compared to liquid fuel. This puts constraints on what kind of payloads can be launched with this technology, as objects that are heavier or more sensitive are unsuitable. Finally, creating a vacuum in a chamber of such a massive size could prove very difficult since it requires a tremendous amount of energy. While the exact power requirements for the spin launch facility are not publicly available, we can take a cue from NASA's Space Power Facility, or SPF. The SPF's vacuum chamber, which is 122 feet high and 100 feet wide, requires 11 megawatts of power to maintain a vacuum. That's equivalent to the power consumption of 3 suburban homes. Given that the full-scale version of spin launch would be much larger than SPF, it would likely require an entire town or city's energy consumption. This groundbreaking technology is currently in its development stage, so it would be premature to dismiss it based on its current constraints. The technology will improve as time goes by, and as it does, workarounds may emerge to address its present technical and engineering challenges. At present, the technology's most viable application is the cost-effective launch of simple space satellites into low Earth orbit. But later on in the future, it could be the key to building genuine megastructures in space, as significant reductions in launch costs could make it highly economical to transport large quantities of material into space. Currently, the International Space Station is the most massive man-made object in space, but with spin launch, it could be feasible to construct structures in space that are 100 times larger for a fraction of the cost. Additionally, an orbital version of the spin launch kinetic accelerator powered by massive solar panels could be developed, and it would not be limited by Earth's forces, such as gravity and air resistance. These facilities could substantially enhance space travel. Astronauts could be launched from Earth into space using Spin Launch's technology and then docked at an orbital station. From there, they could transfer to another spacecraft and continue their journey. With the mitigation of centrifugal force using a counter-rotating platform, the technology could potentially be used to make space travel safer for humans. While there are many potential uses for the orbital kinetic accelerator, not all of them are positive. Just as it can launch objects from Earth to space, the accelerator could be used in the opposite way, hurling objects toward Earth and making it a potentially destructive weapon. This type of weapon could be as dangerous as a nuclear bomb, without the harmful radioactive fallout. Remember the earlier example of a 200-kilogram payload moving at 40,000 kilometers per hour. and what kind of destruction it can cause. That's a launch that originated from Earth. How much more if the same payload is propelled toward our planet at such a speed from outer space? The resulting explosion would put disaster movies to shame. It could cause levels of destruction not seen since the dinosaurs got wiped away by that meteor. No doubt spin launch has the potential to revolutionize space exploration, but it requires further investment in research and development to overcome its current limitations. Once these challenges are addressed, the technology could lead to the next evolutionary step for space exploration with unforeseeable benefits and potential risks. What are your thoughts on this revolutionary technology that can change how rockets are launched in the foreseeable future? Let us know in the comments section down below. Also, don't forget to hit the like button and subscribe to our channel.